Dear friends, today we will talk about the 11th lecture on module 1, where our objective is to focus on safety assurance and assessment. In this lecture we will talk about hazard analysis techniques. This is an online course on HSC and IIT Madras, brace of NPTEL IIT Madras. The moment we talk about hazard analysis procedures, the foremost idea which comes in mind as an important analytical tool is HAZID. HAZID abbreviates for hazard identification. The principal objectives of any hazard study are the following: to identify all hazards associated with the operations of the plant, to create an overview of the risk picture, to provide an overview of different types of accidents that may occur which will rise to given risk, to provide assurance that no significant hazard is overlooked. Friends, HAZID has got a very primary focus in preparing such analysis. It essentially ensures that no significant hazard is overlooked. So, HAZID is nothing but identifying hazards. There are many methods by which an HAZID report can be carried out. You have to conduct surveys, you must interact with people working on plant, you should try to know what are the different factors that are associated with the hazard scenario in the given production unit, and based on that you can prepare an HAZID report. Now, there are of course hazards associated with different plants and equipments, and of course there are hazards during operations of any given process plant. Oil and gas industry is no exemption on this. Hazards with operation are generally taken care of by a detailed study called HAZOP. We have already seen some details of HAZOP study in the last lecture. In this present lecture I will take an example case study and I will explain you how HAZOP report can be prepared for a case study applied to oil and gas industry. When we talk about equipments where we want to conduct hazard analysis for equipments, there are essentially 3 levels of details which are required to conduct an hazard study for equipments. The 3 levels are the equipment level, the subsystem level and the system level. In equipment level, generally all equipments, valves, instruments are identified separately as possible hazards individually. In a subsystem level, all subsystems such as separation stage, compression stage are identified separately as possible hazards. Please understand, at equipment level and subsystem level they are independent and they are local. In system level we globalize them, interconnect them, such as electrical, mechanical and instrumentation hazards. So, electrical, mechanical and instrumentation hazards can include subsystems related to operation, compression, separation stages, etc. They of course also include equipments related to valves, instruments, electronic equipments, etc. So, system level is an integration of hazards in subsystem and equipment level together. But there are different scenarios, there are different advantages, merits and insights of different levels of hazard analysis. Let us quickly see what are they. So, let us ask a question: what are common problems with such divisions of doing hazard analysis? If you talk about hazard preparation or hazard analysis only with the equipment level, you will understand that this kind of hazard analysis generally increases hazards in a higher rate, essentially because the overview of the problem will be lost, as this will essentially focus more on problems or hazards related to equipments. So, hazard analysis at equipment level is a micro level study where the focus is on the mechanical components, the working components of an equipment alone, whereas the interaction of man machine interface is not detailedly cited in HAZOP analysis or hazard analysis done at equipment level. When we talk about system level, let us say the next level, working with system level has some problems because the hazards in this particular level of study will become more generic. Therefore, these kind of studies of hazard analysis done at system level, as they are globally connecting both equipment and subsystem level, they will not generally give detailed insight to the correctness of the problem. Now, there are 3 levels of hazards one can look at. One is the equipment level, which has got difficulties in micro focusing working of the equipment or components alone. The other is system level, which is more generic and more higher order, therefore, it does not give insight to the correctness of the problem. The leftover is the subsystem level, which is the best method to work at hazard analysis. One can ask a question, in the given hazard analysis scenario, what would be considered as the most difficult part? The most difficult part in hazard analysis is essentially to identify the significant hazards that arise from the process. It is very difficult, friends, to know really the hazard scenario that arise from the process. There are many reasons for this. Fundamental reasons are, there is a tremendous variation in the operational temperature and pressure at which the process plant works. Therefore, any variation in the pressure, temperature, etc. during the process stage can result in significant hazards, which is very difficult to foresee unless otherwise you have an experience in such process plants. So, the most difficult task or the part in hazard analysis is to identify the significant hazards that arise from the process. Therefore, the answer to this problem is to do a structured analysis which will help to achieve this mandate. Let us ask quickly an example question. Let us say a gas refilling station experienced difficulties during a specific process. Severe listing was developed to prepare emergency evacuation plan for the process crew. This depends on the experience of the people working on board based on their near miss events in the recent past. A severe listing was developed which will result in an emergency evacuation plan in case of any hazard situation arising in the refilling station. Now, after detailed analysis, it is interesting for you to know it was found that the problem was with the leak of the pressure valve which could lead to fire. Now, dear friends, please understand, the emergency evacuation plan prepared for the process crew focused on experiences and difficulties that were faced by the personnel in a refilling station, but a micro level problem of leaking of a pressure valve was not focused, which was not an attention at all in the whole study, which could lead to fire. Therefore, the pipelines were subsequently checked and tested to correct this problem, and in this simple illustration one can easily understand that hazard identification during a process like identifying a leak in front of a pressure valve, because pressure valve will have a leak only when the pressure crosses a specific threshold value of the valve. So, this is process related problem. So, hazards identifying during the process is very difficult, and that is rather the most difficult task in an hazard analysis. So, hazard identification therefore must be capable of identifying even such minor details also. That is the success of any hazard analysis technique. Now, let us quickly ask a recap how hazard analysis becomes important for oil and gas industries. Oil and gas industries play a major role in world's economy. Huge investments are made to upkeep the facilities in order as well as to increase the production capacity even marginally. Any accident like blowout, oil spill, operational problems shall and has resulted in heavy economic loss to the industry and to the economy of the country. Now, there are several techniques available in the literature to identify and assess these hazards. Remember, these are all techniques which enable you to first identify and then assess mathematically the hazards present in a plant. Remember, hazard and risk are different. Hazard is a scenario, risk is a materialization of the scenario. So, what are the studies available in the literature for identifying hazard and assessing them? In the list, the top is hazard and operability study, which we call as HAZOP, followed by which, focusing on mechanical equipments, people also do failure mode and effect analysis, which is abbreviated as FMEA. Of course, there are quantitative risk assessment methods, QRA tools available to also do hazard analysis. Event tree and fault tree methods are also one of the methods for hazard analysis. We will see all of them in detail in subsequently in different lectures on this module. When we talk about preliminary hazard analysis, because any analysis has got a preliminary and detailed stages of analysis, let us talk about preliminary hazard analysis. This is an analytical technique which is used to evaluate hazards in an early project stage. So, preliminary does not add to the hazard is preliminary, it is only the stage of the project which is early, therefore, it is preliminary. It does not require of course any detailed design, only conceptual form of design is enough to carry out preliminary hazard analysis. Now, what are the steps involved in carrying out preliminary hazard analysis? You have to define the subsystem and the operational modes of the plant. One should identify hazards associated with the subsystem or operations. Define the hazards very clearly that arise during the process. Estimate the probability of events and possible consequences that arise from these events, and therefore, finally identify and evaluate actions that are to be taken to reduce or mitigate or eliminate the probability of occurrence of such events. Finally, evaluate also the interaction effects of various hazards. This is an very important stage in a process plant like oil and gas industries, because we know the hazard scenario of one is highly dependent and interconnected with the other. Therefore, interaction effects must be also evaluated, because there is always a cascading effect of one hazard on the subsequent. Followed by which, the next kind of study what people generally do in hazard analysis is SAFOP. SAFOP stands for Safety Operations Study. It is used essentially for analyzing work processes and procedures. It will only thoroughly review the safety procedures involved in operation in terms of work process and procedures. The essential objective of the study is to only evaluate risk factors of the events. It can be applied to new and old plants as well. It is mainly used for process interventions, material handling, crane operations and maintenance. So, this is a micro level study conducted in every process plant only for process interventions. If we have got any major changes in the process, if you are having a material inventory handling, and when you want to really work out safety regulations or procedures, review the safety procedures for crane operation and maintenance of the entire plant, SAFOP study are generally carried out. The next method available in the literature is bow and tie. Bow and tie method is essentially used to check the efficiency of the safety management system. So, as I said in the beginning, every plant including oil and gas industry do have safety norms very well maintained and available and strictly followed in every plant. Now, it is essential duty of a plant manager to review the safety procedure and adoption of this procedure as per the rules periodically. So, bow and tie concept is one of the method which is used to check this efficiency of the existing safety management systems. Now, look at this figure. There is an hazard scenario present in the plant. This hazard scenario can give threats to different kinds of problems. These threats can trigger off different scenario that can result or cause an accident. Now, of course, as we all understand, in the original design there will be lot of prevention control mechanisms also available in the plant. So, taking care of these prevention and control mechanisms in order, one can easily find out and evaluate what is the possibility or probability of the hazard triggering off to become an accident. Now, the question is, when you talk about accident, it can be an incident, it can be an event, it can be a major accident. So, one can easily find out what is the probability of these triggering events which arise from an hazard scenario, though available prevention control measures are existing, can result in a major accident. Once this probability of occurrence of an accident is evaluated from the procedures, then one can also look at the mitigation control methods what you already have in place, which can be used to control the accident if it has occurred, and if you are not able to control or mitigate 100%, what would be those consequences which are arising from debarring these control mechanisms. So, it is very interesting, the right hand side of this bow and tie or the tie problem talks about the consequences and the control measures. The left hand side, which is the bow, which talks about the scenario and the prevention mechanisms. So, integrally together, this is called a bow and tie analysis system, which is generally used only to review or to check the efficiency of the existing safety management systems in place. So, this shows a relationship between the hazards, the threats, the control factors, the mitigation factors, and subsequently the consequences that arise from the hazards. Each bow and tie is a set of fault tree and event trees. Fault tree constitute the left hand side of the diagram and event tree constitute the right hand side of the diagram. That is a very simple example how a bow and tie diagram can be constituted or analysis can be done for reviewing the existing safety management system in place in the plant. Next to this in the list is cause, probability and frequency analysis. It is one of the quantitative risk analysis methods abbreviated as QRA. This can identify the potential causes that may lead to the accidents. It can also identify the frequency of initiating events, the condition and probability of failure of safety systems in place, probability that environmental conditions that can adverse and cause problems to the plant, probability that severe accidents may occur, probability that personnel may be present in the area when accident occurs. All these are looked into in this kind of analysis where the causes, the probability of occurrences and frequency of such occurrences are all considered in the analysis, which we together call as CPF, cause, probability and frequency analysis, which is also one of the hazard analysis methods adopted in oil and gas plants. Most interestingly and commonly used technique is a fault tree analysis. We will have a separate lecture to explain FTA with an example problem. Let us quickly see FTA is a logical structured process that can identify the potential causes of the system failure. So, it talks about the system in total. It can also focus on subsystem depending upon the requirement or intricacy of the FTA. The FTA will essentially focus on identifying the initial events and identifying the failure of barrier systems. So, it will talking about initially, interestingly, to identify the initiating events and then subsequently identifying also the failure of any barrier systems available in place in a given plant. Followed by which the other list existing in hazard analysis is FMEA, failure mode and effect analysis. It is one of the simplest technique which identifies the possible failure of components of a machine while in operation. So, this is a machine level study or mechanical equipment level study where the failure modes of mechanical equipments are identified and then they are postulated failure and try to understand what would be the consequences of these mechanical components if they fail to perform the intended function. It is based on the practical observation and of course has no sound theoretical basis. Let us talk about an example problem of HAZOP analysis. HAZOP is an important method of hazard analysis used for oil and gas industries. HAZOP is applicable at 4 stages of operation. It can be at the drawing board stage, which is called as a design stage. It can be also done at the construction stage. It can be done during process modifications, can also be done after accident occurs, which we call as AIR, that is accident investigation report. HAZOP studies can be done even as early at the design stage, even as mature as post accident scenarios. So, HAZOP is one of the very powerful tool which is generally used in oil and gas industries to revisit the accident scenarios and to prevent or mitigate such possibility of accidents occurrence in the plant. Now, let us consider a case study. In this example, we will take about group gathering station. Now, before we do a HAZOP study for a group gathering station, let us try to understand the vital components present in the process of a group gathering industry or group gathering station. Now, the focus of the study is to identify the hazard and operability problems of a group gathering station which has a potential to cause damage to the operation of the plant, personnel and also the environment. The societal risk and the individual risk both are encountered, and therefore, this study gives an overview of both personnel safety and asset safety management as well. The objective is also to eliminate or reduce the probability and consequences of the incidents in the installation and operation of the group gathering station. In this specific example, we have used PHA Pro 7, which is one of the popular software which is used for writing HAZOP worksheets. Let us quickly explain very briefly the methodology used for process in a group gathering station. Now, the methodology of HAZOP report follows step by step. In a given process, piping and instrumentation diagram, first let us identify the section of the plant which we call as node of the plant. Friends, please understand, HAZOP report is never done for the entire plant, it is done only for segment wise of the plant. One can integrate the entire plant in order once segment analysis is complete. Therefore, it is interesting for you to know that HAZOP reports intrinsically look into minor details of the process itself. As I said in the beginning, it is always difficult to identify hazards in a given process. Therefore, HAZOP reports form a vital background in any process industry, nevertheless in oil and gas industries also. Once you identify a given section in a plant which is taken from a process or piping instrumentation diagram, define the design intent. We all know what is the design intent and what is the deviation from the design intent, we have already explained in the last lecture. So, for every node of the plant, try to fix the design intent and normal operating conditions of that node. Once you do this, identify subsequently the deviation from the design intent or operating conditions. By applying a system of guide words, we already know there are primary keywords, secondary keywords, pseudo keywords which are available in the literature. We must list them before we start writing an HAZOP report. So, let us identify the deviation using secondary keywords, let us identify the design intent using the primary keywords, combine them in a proper format so that we can start writing the HAZOP report. Subsequently, identify the possible causes, related consequences and also check for the available safeguards for the identified deviations, because all will now form a part of the HAZOP report. Finally, in the last column of the HAZOP report, you must suggest or recommend actions to reduce, mitigate or eliminate the deviations. Now, record the entire discussion and action in a proper format, what we call HAZOP report. Before we start experiencing you to write an HAZOP report for a group gathering station, let us try to understand what is the process happening in a group gathering station, because if you do not understand the details of the process, it is very difficult to follow node wise intricacy in a given node or in a given plant. Now, the well fluid emulsion received at the limits of a group gathering station is distributed into 3 production manifolds. 3 production manifolds which are used for producing crude oil is collected and connected to a group gathering station. Now, they are all now connected to a group main header where the fluid will now flow to a space called bath heater treater. Bath heater treater is basically a container or an equipment or a space where the first level of separation of oil, gas and water takes place. Now, the separated oil from the bath heater treater is subsequently stored in emulsion recipient tanks, which is indicated as ER tanks. The associated gas is separated out and goes to the flash tank, because this gas need to be flared off, otherwise it will increase the pressure which can cause catastrophic disaster. So, this gas has to be flared off. Therefore, once the oil, gas and water are separated, the gas which is separated will be now allowed to flare off, whereas the oil will be subsequently stored in emulsion recipient tank, which is called as ER tank or ERTs. Now, oil is stored in the tank, gas is flared off. Now, the water which is present in the exploration stage at bath heater treater will now go to effluent treatment plant separately, where it is treated and then spilled off. From the emulsion recipient tank, which is now containing only the oil, now the oil is then fed to jumbo heater treater, and you require feed pumps for finer treatment, because this jumbo heater treater will maintain the temperature and pressure which will now treat the oil, or which will process the oil which can be used for commercial applications. In jumbo heater treater, further separation of oil and water takes place, because there are some paraffins present in the oil which should be separated off further. So, in jumbo heater treater, further separation takes place of between oil and water. Now, the separated oil alone is then pumped to common tank form, which we abbreviated as CTF. Now, dear friends, the given process instrumentation diagram has got many stages of process. The first one is bath heater treater, where oil, gas and water together are collected. From here, the oil goes to emulsion recipient tank, whereas gas is flared off and water is going to effluent treatment plant. Subsequently, oil from emulsion recipient tank goes to jumbo heater treater, where it is further treated and the water goes as a steam off, whereas the oil is then taken separately and fed and stored into CTF, which is called common tank form. Now, let us see the process instrumentation diagram of this plant. Now, the figure on the screen shows you the process instrumentation diagram, where the process is explained slightly in a graphical manner. These are all the non-enhanced oil recovery headers, which we call as sub headers, and which has got a group header 1 and group header 2. Both these now collect the crude oil, which is mixture of oil, gas and water, which is now fed to bath heaters. From the bath heaters, oil alone goes to emulsion recipient tank, the water is taken to the effluent treatment plant, the gas is flared off to the flare boom separately. So, from the emulsion recipient tank, the oil further goes to the jumbo heater treater. In this particular plant taken for the study, there are 4 jumbo heater treaters, there are 5 to 8 emulsion recipient tanks, there are 1 to 5 bath heaters. So, from the jumbo heater, the oil which is now separated further from water is stored in the storage tanks. From the storage tank, it is dispersed off through the pump house to common tank form. So, briefly understand, this is a segment which I am going to analyze, which I marked in red. Now, interestingly, there are many group headers, there are many bath heaters, there are many enhanced oil recovery production separators and flash drums available in the process plant, but my HAZOP study is limited to only the present scope of the study, focused only on the red marked portion, which is now the designated node for my hazard analysis. So, my HAZOP is now focusing on a specific segment of the plant, which is called as designated node in a given plant. So, from the given diagram it is mandatory for us to designate a specific area for defining the scope of the study. From the scope of the study we start writing hazard report for the specific envisaged hazards given in this segment of the plant alone. One can ask me an interesting question: if I do hazard analysis through hazard report for different segments of the plant separately, how do we integrate them, because the whole plant has got to be integrated for the final hazard analysis report. How do we integrate? Interestingly, this is where the software helps us to know how they are integrated. While I do the example, I will explain you how they can be integrated also. So, the nodes marked in the process flow diagram of a group gathering station is shown to you on the screen now. Let us start working at the hazard worksheets. We are using PHA Pro 7 for working out this specific example for you on academic interest. Before we understand writing an hazard report, let us try to clarify certain issues how the nomenclature is given in an hazard report. We have already seen in the last lecture, hazard report intensifies the design intents and deviations from the design intent. If it is so, then primary and secondary keywords are recognized and listed in the beginning of the report. We should also know how nomenclature can be easily attached to this kind of report. Let us see this risk matrix which is generally adopted in oil and gas industry. The risk matrix has two segments: the hazard severity indicated as S, the likelihood occurrences indicated as L. Sometimes it is also called as HS or LS matrix, hazard severity versus likelihood of occurrence. The hazard severity goes higher and higher towards the right hand side, whereas the likelihood of occurrence goes higher and higher towards the bottom of the screen. So, this is the higher indication. Similarly, this is the higher indication for severity. On the other hand, these segments are all low severe, and whereas this particular segment is higher likelihood, etc. Now, the entire matrix is divided into different areas and zones, where the nomenclatures established in the literature are given as A, C, N and U. So, A stands for the regions where acceptable risk, that is, no risk control measures are required. If you are identifying a specific risk zone or risk region as acceptable, you do not require any additional risk control measures. What is available in the plant is sufficient. The regions where N indicates are not desirable, therefore, one must activate risk control measures must be introduced within a specific time period in a given plant. The regions where C is indicated, they are acceptable with control, provided the risk control measures are available in place and recommended strongly. Whereas regions which are marked red in color here, they are unacceptable, therefore, one should not try to have any such regions in a given plant. So, the risk matrix dividing the entire hazard severity and likelihood are appearing here. Now, let us look at the cases of the classifications of hazard severity, starting from no injury, minor injury, injury or moderate health impacts and death or severe injury. So, the hazard severity is increasing towards this way on a scale of 1 to 4, whereas the likelihood occurrence were not expected to occur, could occur only during facility of the life, could occur several times during facility of the life, could occur on an annual basis. So, if a specific hazard which causes no injury, which is not expected to occur, falls in a category A, which is acceptable. If an hazard results in fatal end or death injury, which is also occurring on an annual basis or could occur during the facility, is categorized as unacceptable. So, this risk matrix, friends, will give you an idea how one can classify risk in a given plant in nomenclatures varying from A, N, C and U. This is how literature classifies hazards in a nomenclature style. So, this will be used in the hazard report. Now, let us look at the sheet available to you in the screen. This sheet already focuses on a specific node selected from the given process flow diagram. Now I have selected the group header. The nomenclature given to this is number 1, which is generated automatically from the software. The group header consists of 12 inches pipeline, node designated as 102 A3A classification. So this can be taken from the standard database available in the software. Now interestingly, I am identifying the failure as a pipeline failure, and please see here I am writing explicitly the deviation. Now the deviation indicates two words, one is the first word followed by the second word. Now there can be low flow, there can be no flow. So both are deviations for the design intent. Now the design conditions for a given specific location is indicated here, which will be the liquid rate of 2500 cubic meters a day, the glass flow rate is negligible, the operational pressure in this specific header is about 10 kg per centimeter square, the operational temperature is 50 degrees Celsius, viscosity of the pure oil at an operating temperature is 270 centipoise, density at the operating temperature is about 15 API, which is closely 966 kg per cubic meter. Now once you identify the design conditions and the deviations what you want to focus on the pipeline, let us now look at only the causes, the consequences, the safeguards and recommendations, which are of course the classical form of writing an HAZOP report. The one what you see here in the middle is an advantageous column which is added to the HAZOP report, which classifies the risk ranking depending upon the hazard severity and the likelihood. Now let me try to explain one of them in detail. Let us take leak or rupture of a group header line, which is designated as 12 inches pipeline 102 A3A. So once we enter it here, automatically the software takes the database from here and enters it here automatically with the node number 1. Once the node number 1 is indicated, it is automatically mentioned to the group header as shown here. Now the consequences of this cause of rupture of the header line can result in fire, it can cause environmental hazard, it can cause loss of material, can also result in process upset. Now look at one specific example of a fire hazard. The fire hazard, if occurs, you have a safeguard system, you will have fire protection or firefighting devices in place which are available in the plant, therefore you indicate that in the safeguard column here. However, you recommend a pressure transmitter which is to be provided in the header line, so that excess of pressure generation which indicates a leak in the rupture of the line can be also mentioned. Now let us look at this particular matrix of risk matrix. The severity, if this kind of occurrence happen, is on the scale of 3, whereas the likelihood of this in the scale of 2. Dear friends, these numbers on a scale of 4 is purely dependent on how your experience in this kind of process plants. Now based on this, refer to risk matrix. For example, get back here, based on the number given for severity and the number given for likelihood, you will know in which category of nomenclature you are falling. So based on this, you know the risk ranking is falls on nomenclature C. So nomenclature C means acceptable with the control mechanism in place. Now the control mechanism available in place is fire protection system. So it is very interesting for us to know, at least for one specific case, once you enter the group header node with the specification, the software borrows the nomenclature, enter the data here, you enter the causes yourself and it is given a number. Once identify the cause, look at the consequences, check what would be the relevant severity and likelihood of this cause and consequence depending upon your experience. Once you have this, the risk ranking is automatically done by the software depending upon the matrix already available in the database. You also give a recommendation. Similarly, the loss of material, severity can be 2, likelihood can be 2, it also falls in risk ranking C. On the other hand, if you have a process upset, the severity of this can be 1, the likelihood can be 2, whereas this product forms in an acceptable level of A, therefore, there is no additional safeguard recommended for this. Based on the severity level and the risk ranking, you can also try to give recommendations like periodic inspection can be done for the plant, the thickness measurement of the header line can be also done, periodical hydro testing should be done to check whether there is any leak available in the plant or in the pipeline, etc. Similarly, the next cause could be isolation valves in the inlet crude oil. Again, the same designated node is studied and the number is 2. For this, the consequences could be, if I isolate the valve, it can pressurize the upstream side, can cause a severity of risk ranking C, whereas the process upset can cause a risk ranking of A. The non-return valve in the inlet crude oil can also fail. If that is the case, the precipitation will happen, which will cause risk ranking as C. Of course, there are pressure gauges available to check the functionality of the non-return valve. However, we also recommend pressure transmitter to be provided in the line to check any failure of non-return valve. Similarly, one can look at all these numbers automatically done. Please understand, interestingly, the recommendation columns are getting generated a number like number 1 shows pressure transmitter provision, number 2 shows periodic hydro testing, number 3 shows periodic inspection. Now, when you look at the second cause, when your recommendation goes as pressure transmitter, the number is automatically borrowed from the database and it is repeated. So, this need not be typed again. Once you say number 1, you will automatically see pressure transmitter will be involved. Similarly, when you recommend any new thing, it gets a new number. Say periodic inspection and maintenance of isolation valve, it is a new recommendation in the report, therefore it gets a new number. Subsequently, in the non-return valve, which is the third cause, you are recommending a pressure transmitter, it borrows a number from the database automatically, whereas if you give any new recommendation for the non-return valve, it gets a new number 5. Subsequently, whatever you give old recommendations, they borrow the same number, whatever new recommendations you type, they get a new number. So, this is how the recommendations for different nodes done in ASAP report are integrated for the entire plant. So, you need not have to do ASAP report for the entire plant yourself, you do node by node, and every report in such order electronically can be integrated by simply preparing the recommendation column, looking at this, and you can easily find. Subsequently, this software also has an advantage. Whatever risk ranking which is on the alarming stage, like for example C, U, etc., which are unacceptable, then they are separately listed and they can be also called for immediate attention. So, writing an ASAP report definitely requires identification of keywords, primary and secondary, identification of the causes and consequences, and subsequently converting them into a quantitative statement which is called risk ranking. Dear friends, please understand, ASAP report is qualitative, but it is also converted into a quantitative number by which the risk ranking is given, based on which I can easily take actions for the given plant. So, there are different nodes available and consequences are identified, and in the same manner we keep on identifying the risk matrix, and we also look at the existing safeguard measurements available, and subsequently we give the recommendations. However, how many number of times I give the same recommendation, the number is borrowed from the standard database which is available and created by you. So, this is the other node which is group header. Now, the deviation here is number 3, it is a new number, reverse flow or misdirected flow. The earlier case was no flow or low flow. So, whatever deviation you give as new, it acquires a new number, and for this new number again you can identify the causes, the consequences, and if there is any safeguard and the recommendations. If you give any new recommendation, it gets a new number. If you give a new recommendation, it gets a new number because it is periodic inspection of the butterfly valve, whereas the periodic inspection gets a different number if it is adapted to the group gathering header. So, whatever recommendations you state, they all will be converted into a specific number, and this can be reiterated so that you can know what are the recommendations given for the plant. Similarly, the report can be done for different headers, for different segments, for different deviations as shown in the subsequent slides. So, external fire, high temperature in the pipeline, recommendations, a new number, number 10, etc. Now, we know that what is the meaning of these risk ranking matrix in categories of A, C, N and U. We already also have these nomenclature present for different causes in a given plant node as C, A, etc. Based on this, one can easily know what are the acceptable risks involved in the plant, what are unacceptable areas of risk involved in the plant. So, HAZOP study has very serious implications. The cost toward implication or implementation of recommended adversely affects the safe mode of operation. Suggested recommendations are required to be implemented, that is mandatory. The total cost of implementation in this specific example resulted in about 18.67 lakhs. This influences the implementation of the recommended action plan if you want to really implement them. However, becoming safety first, HAZOP reports recommendations are strictly implemented in the given plan and they are revisited subsequently by the next team of HAZOP management. In this specific example, we have understood that all identified hazards of the given installation in a group gathering station can be reduced or eliminated because there is no U category of risk involved. Cost of implementation influences the implementation plan accordingly. Risk ranking gives very interesting idea, and the highest order in this case is at node 2 and node 5, which is jumbo heater treater and heater treater, because these are the areas where the focus of risk reduction should be done by the plant. Recommendations of U and N category in this case are not available in this study, only A and C are denoted, therefore the plant is safe. So, this example made you to understand how to write a HAZOP report for a given process station. HAZOP is a qualitative method of writing a report. This example illustrated how to prepare an HAZOP report, and this lecture gave you different hazard analysis methods briefly. Thank you very much.